Hello everybody, my name is Halo. Welcome to this video series where we are solving Codeforces problems. In Python, we are doing the A to OJ ladder, and in this video, we're solving problem 80A, which is called Panoramix prediction. It's again a very easy problem. Let's just go ahead and look at the solution. Right, so let's just read through the problem once before we attempt to solve this question. This problem is called Panoramix prediction, and yeah, that's what they say. So basically, what they're saying is the next prime number after a number x is the smallest prime number greater than x. Okay, so all of this is not necessary. I mean, this story is also not necessary, but they're saying this Panoramix prophecy tells us that if someday asterisks and obliques exactly beat x Roman soldiers, where x is a prime number, and the next day where they beat exactly y soldiers and y is the next prime number after x, okay, then it's time to wait for Armageddon or not, or it's not. Okay, so I mean, I think this output line is all you need about this question. Given two integers n and m, you're supposed to find out if m is the next prime number after n. Okay, so what does next prime number mean? As we said before, there should not be any prime numbers between n or m. Okay, so when you're looking at a prime number, say 3 being n, m should be probably 5. So if n is 7, m should probably be 11. Okay, so there should not be any number between these two numbers which is a prime number. Okay, so how do you solve this question? One thing that we're generally looking out for in questions like this is whether we can apply a brute force solution or not, because this looks like a brute force problem to me. And one thing that you can check to see if you can apply a solution is looking at these two numbers, which is m and n. Okay, so when you're looking at numbers say up to 50, if you're doing two for loops, that will be 50 into 50, that is still 2500, which is way less than 10 power 8 operations which can be done in 1 second. So yes, we can go for a brute force solution, and so should you when you're working with prime numbers. So how do you solve this? It's very simple. I think let me just get the eraser and go a bit down so that I can explain this a bit. So given two numbers, okay, 7 and 9, what you're going to do is from this 7, you're going to loop from 7 to, okay, 9, and you're going to check for all prime numbers between these two numbers. This is n and this is m. In case there is a prime number somewhere, let's just say there is a prime number in between this, in that case obviously this value will become no. So if you find a prime number which is not m between n and m, which means m is also includes only, your answer will be no, or else it will be yes. How do you find whether something is a prime number or not? So a case where this you can do is, let's say 7 and 13, there's a number called 11, this becomes a prime number, therefore the answer is no. If it's 7, m is 11, then the answer will be yes. Okay, so how do you find out if something is prime or not? It's very simple. So first of all, we know that we are going to loop from n to m, that thing we know. And to find a prime number, what you do is, let's say the number is 9, okay, or let's say it's 11, that becomes a lot easier. Some things to keep in mind is you're going to be looping this, okay, you're going to check for numbers 1 to 11 if there is a factor in this particular number. Okay, but you don't really have to check till 11. You can actually check till half of this number. So what that kind of means is you can check till 1 to 11 by 2 inclusive, so that will be 1 to 6 probably. And if you check between these numbers alone whether this is a factor of 11, you can kind of confirm whether it's a prime or not. Okay, so that's how that works. I hope you guys understand how the concept of prime numbers work. If you have any doubts, let me know down in the comments. I'll be glad to solve those. Okay, so in this case 11, what we're going to do is first we're going to take the number 2. In fact, it's not even 1 to 6, it's actually 2 to 6, because 1 to everything is a factor of 1, right? So you don't even have to include that. So you say if any number between 2 and 6 divides this particular 11, you're going to say that, yeah, no, it's not a prime number probably. If it does not, then you're going to say yes, it's a prime number. Okay, so first you're going to do 2, so 11 percentage 2 is definitely not 0, this is gone. 11 percentage 3 definitely not 0, 11 percentage 4 definitely not 0, 11 percentage 5 definitely not 0. When I say percentage, I mean modulo operator, of course, and 11 modulo operator 6 is also not equal to 0, therefore 11 is a prime number. That is something that we know. Okay, this is something we have passed. We are looking for n is equal to 7 and m is equal to 11. Now the next condition to check is whether this next prime number is equal to m or not. Okay, so when it's 7 to 11, you're going to check for 8, you're going to check for 9, you're going to check for 10, and you're going to check for 11. This is not a prime, this is not a prime, this is not a prime, this is a prime, and this prime is equal to m, which means this prophecy is solved and the answer is yes. If this is not equal to m, or in any other case, the answer will be no. So I hope you're able to understand how we are solving this. If you can understand it, you might as well put that into Python notation and try to solve this problem for yourself. If you're not able to do that, stick around for the code. Okay, let's solve this problem. First things first, we need to take two integers as input. So that will be n and m. We can just go to list of map of int comma input dot r strip dot split. If you guys don't know how that works, it takes a string, it gets rid of the last trailing space, then it splits that string, converts that into integers, mapping that into integers. So you'll get a list of integers, and when you put this to a list of integers, it'll automatically assign the elements into these particular variables. Okay, so n will be 3 or m will be 5 or however that works. That is what this line does. Then what are we going to do? As I said before, we're going to be looping for I in range of n comma m plus 1 because m is also inclusive. Okay, and for every I, we're going to be doing a prime check. For every I. Okay, so we know what m is already, right? So we can set, okay, set prime status. Okay, let this be something like false. Okay, and yeah, and let's set a main status also, which is the answer. Okay, so initially just assume that the answer is no, because in most cases it will be no. Unless all of this pass and it becomes m, then only we'll change this to yes, or else we'll just keep it as no. That will be much easier for us to print out. Okay, so let's just set this prime status to false. It does not need to be a string, you can just set that to an integer. Yeah, and then what you're going to do is for j in range of, as I said, 2 comma I 2, but this is also inclusive. Okay, so this is what you're going to be checking with. You don't have to check every number from 2 to I. You can just check I 2 by 2 and that inclusive. Okay, yeah. So then what you're going to do, let me just close this out so that we can code a little bit better. If I percentage j equal to 0, that means this prime state. Okay, let's just say the prime status is true immediately. Okay, and now we can change this prime status to false. Okay. Now, once we go through all of this, okay, now if we go ahead and say, okay, we have one prime number, because we only need the nearest prime number. Okay, so we only need the nearest prime number. So what we can do is, since we are iterating from n to m plus 1, we can just check whether this prime status is first true or not. So we can say if prime status, right? If it is true, first things first, we can break out of this loop. Yes, because we only need the nearest prime number. What do we check? It's very simple. We check whether this m, if m equal to this particular number I. Okay, that's it. We just need to check if this number that we're checking, which is a prime, and our m is the same number, which means the answer will now be yes. Okay, and that's the only condition we need. We can then go ahead and break out of this loop. Okay, so that's it. If we found the nearest prime number, it is not what m is, the answer is obviously no. The answer will still remain no, right? If it is there, obviously the answer will be changed, and in either case it's breaking. We don't need to check for the next prime number because we only need to check this for the nearest prime number. Okay, so once we're done with this, we can just go ahead and print the answer value. And then one more thing we are going to be doing is this I should be starting from n plus 1, because obviously this part right here is inclusive when you're doing a for loop. We don't need to check n value again, we need to check the nearest number, so that will be plus 1. I already explained that in the solution. I forgot to include that in the code. So if you're running this, as you can see, all the test cases have passed. Let me just go ahead and submit this as a solution to see if this works out. I think it should. And yeah guys, so as you can see, the solution is accepted. This is the solution for this particular problem. The problem's name is Panoramix prediction. Again, I hope this video helped you. If it did, hit that like button below. If you guys have any questions, or if you have a different approach to solve this particular problem, let me know down in the comments. And if you guys want some other specific problem, let me know that as well down in the comments. Thank you so much for watching. I'll see you in the next video. Until then, bye.